Moving on to architecture of 8085. So now when the input signals are given to the bus, this is called as an address bus or the data bus, which takes all the information and passes through the information. So serial in, serial output. Serial input, it takes all the inputs and it sees whether we have any interrupt or not. So these are called interrupt controller. Serial input, once the input is given, it passes through the accumulator. Accumulator sees what arithmetic should be done, to which accumulator should be sent. So it passes through. And temporary register, temporarily the input what is getting, it is stored, and then it passes through ALU. ALU does all the arithmetic operations. This bracket thing shows how much bit registers they are. So this is an 8-bit. So arithmetic operations, ALU tells what operation to be done. Accumulator tells what operation to be done. Then it passes on the message to the address bus. Then again it comes to the instruction register. Instructions, the instructions which are passed by the ALU is done in instruction registers, that is addition, multiplication or storing, dividing, what to be done. Then multiplexes, the registers are stored in this form. So W, Z, B, C, D, E, H, L, and the stack pointer and the program counter or increment or decrement the address latch. So now 8-bit, if it is an 8-bit input what we have given through the accumulator, it stores in an 8-bit register, AX, BX, like that. In 8-bit register also, if it is 8086 16-bit, then we have to we'll be storing it in stack pointer in 8085. Then it passes on through the address buffer, that is A15 to A18 is one address buffer called. Then data and address buffer, that is why it is AD7 to AD0. So when it is having a high clock pulse, it is passed through address. When it is low, it acts as a data bus. So that is why it is a multiple, that is data and the address bus. Now coming to the control unit, timing and control unit. This control units controls the whole microprocessor architecture of an 8085. So clock out, so that we use here 5 volts and ground as the power supplies. This is the most important part. And ready, read, write, ALE, SO, serial out, serial input, IO, M bar, hold, halt, reset in and reset out. Okay, this is the basic architecture of an 8085. Moving on to what diagram description, each performance. Okay, so now register unit, that holds programmable registers for ALU operations. Then arithmetic logic unit for performing arithmetic and logical operations. Instructions register holds the instruction from memory and passes it to the instruction decoder. That's what I told. It passes so that it decodes, then decodes the information of the instruction. It passes to the timing and control unit for necessary control. Timing and controls, decodes and generates the necessary timings. Interrupt controller. There are two types of interrupt, that is vectored and non-vectored. Vectored interrupt is predefined. That means the microprocessor already knows what the interrupt would be. Example, like close the window without saving. If you say so, it will come that you have to save it and then you have to close it. That times microprocessor already knows that what interrupt will be there. Non-vectored interrupt is non-predefined. That is, microprocessor will not be knowing what kind of interrupt will be there. Okay, suddenly when you are trying to open some other website, so suddenly you will get an information telling that allow block. So microprocessor will not be knowing those kinds of instructions. Then maskable means discard it. Continue and postpone. You can tell it as save later or close later and then you can continue. Non-maskable is non-discardable. That means you have to immediately solve that whatever the window that will get opened. Okay, now serial input and serial output control unit is used for serial data communications, where at the same time you can pass the input and pass the output. Multiplexer collects the data and gives the instruction to the register. Registers are programmable and general purpose 8-bit registers. Adder latch forms an pair of 8-bit registers to store the data. Temporary register, it stores the data temporarily 1-bit operator, each bit in each operand. Now, what is a stack pointer and the types of flags? Stack pointer, it is an 16-bit register. Combination of two 8-bit is called a 16-bit, and the stack is usually accessed by LIFO, that is last input is the first output. This means now you are passing on 1001. So the first register is taken by, if this is the register path, first is stored is 1, the next 0, the next 0, the next is 1. So the registers are stored like this, but the first reading will be done with the topmost part of the register. That is what is the meaning that last in first out. Last is the input of this one, but first will be read will be the topmost part. So this is what last in first out meaning. So then coming on to program counter, 16-bit register that is used to control the sequencing of the execution of instructions. Now flags, there are 5 different types of flags. Shows the status after the ALU, the 8-bit register. So that is zero flag, sign flag, auxiliary flag, parity flag, and carry flag. What is sign flag? The sign flag is set. Set means 1. That means it is high. If D7 of the accumulator is set to be 1. For example, if I am taking so this will be my D0, D1, D2, D3, D4, D5, D6 and D7. So here the D7 is set to be high, 1. So the accumulate, that is why it is called as 1. That is why this one will have 1 value here. Okay. Zero flag, the result of the ALU. If you are doing addition, so addition of 1001 and then 000 only you are adding 000, the result will be 0. If the result of the two numbers if you're getting, then it is set to be high. ALU is 0, then it is set. If the total result, then it is gonna be high, or else it will be 0 if you have the result as 1001 or any other 0001 also, then it will be under the reset condition. So auxiliary carry flags, if there is a carry from D3, that is from D3 to D4, or when you have a carry, example 1, example I'm taking like this. So 1 plus 1 0 1 1 0. Here see, now this is gonna be a carry D0 D2 D0 D1 D2 and D3. So this is gonna be carry. So if this carry is present, then the auxiliary carry is set to be high, that is 1. Otherwise the other condition is reset. Parity flag, after ALU operation, if the result has the even number of ones is set to be 1. If it is having odd number of ones, see here, now 1, here 1 1 1 0 and 1. See, now 1 2 3 4 5, there are 5 ones, so it is odd, so the parity flag will be 0. It will be under reset condition. Carry flag set when the result of the ALU generates the file. So this is generated out. So this is gonna affect the carry flag. So if this is present, then the carry flag is set to be 1, or else it will be 0.